So yeah, welcome everybody. I do realize this is the second talk after lunch. I'll try to keep you awake. But if you do feel the need to yawn or something, please don't yawn at me, or else I'll yawn and there'll be more yawning, and the replication of yawning might overload my brain. Anyway, so I'm a principal developer at the platform engineering team at MYOB. And today we are going to talk about some Kubernetes-related stuff, which I forgot to, I think, take the clicker. No, here it is. Cool. Just a very quick note, this talk is going to be high-level Kubernetes stuff. So if you're not familiar with Kubernetes and if you feel lost during the talk, please come reach out to me afterwards, and we'll definitely try to clear up some things. But it's going to be a high-level journey, kind of a story as to how we approached adopting Kubernetes organization-wide, because it's a new technology. And you know, when you say to your managers, I want to run Kubernetes, they'll go, oh, well, you're after new and shiny. But you have to drive that adoption. So I'll share the story today, how we did that. This is a very rough agenda, which is we'll talk about what MYOB is, and first define the problem space, because obviously adopting a new changing technology, there has to be a problem which it was solving, or else why would you even make a change? So we'll look at the problem statement, and then we'll walk over the solution as to how we implement it. And when we talk about the solution, you will see some cues as to how we drove adoption. And finally, we'll wrap it up with how we actually drove adoption and a conclusion. So what is MYOB? MYOB helps make business life easier. The way we do it is we build taxing and accounting software for small and medium enterprises, and also for larger enterprises as well. One of the key values at MYOB is you should be up at night for your business, for your passion, not for your accounting, not for your taxing, not for your payroll. With 50+ products, we got your back. We'll help you with that kind of stuff. But what you should be worried about, what you should be focused on, is just your product. We remove the undifferentiated heavy accounting. It's a term I made it. I can have the copyright for it. And also, we've been around for 25+ years, which makes us a big player or whatever. But remember that has an implication. Being around for 25+ years has an implication. So talking about MYOB technology, MYOB tech, at MYOB, we have 50+ highly autonomous teams. Now, there's been a lot talked about autonomy in the keynotes and the session after that and the session before this. I think, and this is again a controversial statement that I'll make, autonomy is not a problem. Unbounded autonomy is a problem. If you have a bounded autonomy, if you give people 5 choices and they're free to select one from the 5, it is not a big problem. But unbounded autonomy is certainly a very big problem. And most of the companies start with this unbounded autonomy. Why? Because they read somewhere that autonomy is good. DevOps, they said. Give them autonomy, they said. And that is where you run into problem. And how do you run into the problem? So at MYOB, we've got 50+ autonomous teams. That means around 150+ AWS accounts. Applications are written in every language possible, means many, many stacks that we have to look after. Now we got a multi-cloud presence as well, AWS, Azure. Thank God we don't have Google. No, but Google is good. I'm not saying Google is bad, but. And the good thing is most of the newer software is being packaged as Docker containers, which is good and bad in a way because there are a lot of containers. How do you deal with the volume of containers? You need some sort of an orchestration tool for those containers now. Only if there was one that existed. And this is the actual problem. Nobody will address this elephant in the room, but I will. What do you do with these many Docker containers? Like, everything is packaged into Docker containers. The other day, I wanted to share a secret, and this guy goes, I'll package it in a Docker container. I'm like, you serious? Why? But hey, there are containers, and because of those containers, we have jobs. So anyway, I'll take that. But the good thing about Docker containers, it provides you a uniform packaging format. So if you're building Ruby, if you're building Python, and if you like to hurt yourself and you're writing in PHP, it gives us a uniform transformation of artifacts. We don't have to worry about how will I transport my PHP zip files, how do I transfer my zip files of jars or whatever, Docker gives us a uniform way of transportation of artifacts. Yes, everybody agrees with that. And I like the benefit of that because I don't have to worry about managing different repositories. But now, the problem. Let's look at the problem. And let's define this because keeping in these constraints, we will walk over the solution and we'll see how we drove adoption using this. So one of the biggest problems with autonomy was there was a proliferation of container orchestration engines, mainly ECS because MYOB is heavily based on AWS as well, and every team was trying to run their own ECS infrastructure. Every team was trying to build something, manage their own infrastructure, do their own operations, do their own security. Now, I think most of us have been there. I was a developer at one stage. I always wanted to finish up my code, and then when somebody asked, have you thought about security? I'm like, yeah, it is secure. And that's it. That was my answer. And that happens. Let's just be honest. It happens. I am not lying. So think about it. If teams, developers want to do their security, it's good they're conscious about security, but they don't have enough time. We have to empathize with them. They have enough to build already. Yeah? And interesting things started happening because our centralized team thought, OK, we'll probably write some patents, and people will use those patents, and it should be fine. It should be fine, they said. We wrote patents. And they started drifting. We had CFN DSLs for CloudFormation. We had Terraform, Chefs, Puppets, Ansibles, you name the thing. We had it. And that was a problem for us. Like, as DevOps engineers, when you see, OK, you go with the perception, OK, I can help this team, and you go there, oh, wait, hang on. You've got something totally new. You should get that checked by a doctor. And those sort of problems we were dealing with. And every team, like 50-plus autonomous teams trying to solve the same problem, trying to do the same undifferentiated heavy lifting, that was a cause of concern for us. The other big problem was the time to production was weeks, months, not days, not hours, weeks and months. Why? Because every team was trying to make their application production ready. Now, ready for prod, what does it entail? So that word cloud is really very scary. And there are big, heavy terms. And for most of us, it might not be heavy, but TLS, DNS, people are scared with these things. In 2018, it is still a problem. And when you ask developers, is your application ready for prod? This is what you get. This is really what you get. And I'm being very honest, and I'm sharing our story. So think about this. We've got 50-plus odd teams, and this is, let's do it as a case study. We've got 50-plus odd teams. They're doing the same things. Wouldn't it make sense to have something common? Wouldn't it make sense to run something like in one place? So guess what? That was our solution. Our solution was Project Jupyter. Now, you'll say, what is Jupyter? Jupyter is, and it's powered by Kubernetes based on AWS. And it's not just plain Jane Kubernetes, you just get it from the internet, run it, and you have Jupyter. No. Jupyter was something which had built-in capabilities. It was the thing that every developer wanted. Nobody wants to run their own monitoring solution. They want to write code. And what Jupyter does is it removes all the undifferentiated heavy lifting from developers. All you have to do, if you're a developer, bring your own Docker image. As easy as that. Some people might also call it serverless, but I don't want to go into the controversy of serverless. But for our teams, imagine, for our teams, they don't have to run any services. They can focus on solving interesting problems. Not that one, but interesting problems. They can focus on building solution, accounting, and payroll, and all of that for people who need it. For small mom-and-pop shops, they don't want to deal with accounting. That's why we are building the software. That's why we get paid the big bucks. And that is what Jupyter was. But, it's a very high level. Yeah, you build Jupyter. It solves things. Let's break it down. What I'll do is I'll break it down for a couple of steps, like 2 or 3 things we'll talk about Jupyter. It should make sense. If it doesn't, please hit us up after this, because I'm very passionate about this. I'm also one of the co-organizers for Melbourne Kubernetes meetup, so I'm passionate about Kubernetes anyway. So if you have any questions afterwards, please hit us up. So let's break it down. How did we do it? And we'll cover this at a very high level. Unfortunately, 30 minutes is not enough for me to go in depth into Kubernetes. And I will assume that you know some Kubernetes terms. If you don't, let's have a chat afterwards. So the first thing was, what we did, we built one cluster, one production cluster for the entire org. One production Jupyter cluster, which is a container orchestration and management tool for the entire organization. No proliferation of ECS agents. We can't have our team members going to multiple accounts and fixing their ECS problems. Because with that proliferation, you'll get underutilized instances as well, which is, again, a big cost problem. So one cluster for the entire organization. Now, the benefit of this is you can have a centralized teams of operational experts, AWS experts, who are building this cluster. This is a centralized team with the common focus of just running that cluster. Operations, security, they're all centralized. You can have a group of cluster admins which are just building capability on this cluster. Yeah? A handful of people can do this. Whereas with 50+ teams, if you do distributed DevOps, distributed anything is horrible. Or sorry, difficult, not horrible, difficult. Distributed DevOps, it's next level. So with this, you got a central team of admins, cluster admins who are looking after the cluster, less operational overhead. And the best thing was the support roster was simplified. How was it simplified? The cluster admins were responsible for the infrastructure. So if we are familiar with AWS and their shared support model, AWS is responsible for the underlying infrastructure, and we are responsible for what we run on top of it. Yes? Everybody agree? This was the same model we went with Jupyter. We, as cluster admins, are responsible for running and operating the cluster, building capabilities on top of it, and developers and dev teams were responsible for running their apps. It's just a clear separation of duty. They don't get woken up if, let's say, a load balancer is failing. We do, and we fix it. They don't even have to know about it. And the other thing, and I think this is the biggest benefit of having one cluster, is one team can learn and benefit from other teams' mistakes. So, for an example, one of our teams, without notifying us, obviously, started doing performance testing on their application. And guess what happened? The ingress or the load balancer to the cluster broke. Initially, we were like running around like, what the hell is happening? Are we getting hacked? Are we getting port scanned? Or what's happening? But ultimately, we figured out, OK, this is the performance test that is causing these problems. Now, once we fix this, once we fix the bug with our ingress, guess what happened? Every single team got to benefit from it. Yeah? Now, one key thing which is the second point, and I didn't mention, is the way we operated this cluster was every single team or tribe in our organization got a namespace. Yeah? If you're not familiar with namespace, think of namespace as a virtual cluster on top of your actual cluster. Yeah? Just if you don't understand Kubernetes, that's OK. Just remember this. A namespace is a virtual cluster on top of your actual cluster. And we utilize some things called resource quotas and limits on those namespace and gave it to teams. Yeah? The last point on the slide, which is the shadow namespace pattern, our solution architect, Paul, came up with this. And this is a very genius idea. And I'll just quickly share it with you. And if it doesn't make sense, don't worry. In the next slides, it will be apparent. So what we did was, when we provisioned a namespace for a team, and actually, let's have a look at the diagram. When we provisioned a namespace for a team, let's say green team wanted to be onboarded onto a Jupyter cluster. When we provisioned a namespace for them, we also provisioned something called a shadow namespace for that team. Now, what this shadow namespace is, like we've been using this concept for ages. But previously we used to call them service subnets or management network or things like this. Shadow namespace was a similar thing. We wanted to run some infrastructure, some capabilities for the teams, but did not want those capabilities to interfere with their regular workloads. Is that fairly clear? It is confusing, I know, but it will be apparent in next few slides. But the overall concept was you provision a namespace, you also provision a shadow namespace. In the shadow namespace, you provision all the supporting infrastructure for that team. And that's it. It's as simple as that. And we've been doing this as an industry for a while, like management networks, subnets, and whatnots. Once we did that, what we did was we installed these capabilities. We built these capabilities in the shadow namespace. And capabilities like auto-scaling, DB provisioning, TLS, security and compliance, all of this was baked into Jupyter as features. So any team that got onboarded onto Jupyter, if you brought your Docker image, you get all of this for free. You don't have to write any piece of code, or you don't have to even write CloudFormation for any of this. You got all of this for free. And talking about adoption, these capabilities is what drove adoption. The more capabilities we offered, the more adoption we could see. And we certainly see, when we deployed our TLS monitoring and alerting systems, we saw a spike in adoption. So much so that we had to rate limit the requests for adoption. Is this fairly clear at the moment? The built-in cap. And to be honest, things like TLS and things like Route 53 should not be a problem in 2000. One would hope, but they are. They're difficult. When you're under the time pressure of building a feature, you've got 2 weeks from a product owner that you have to finish this, you don't think about TLS and Route 53. You think about when someone is doing a deployment and it fails. It happens. It's unfortunate, but it happens. So what Jupyter was, we will offer all these capabilities to you out of the box. All you have to do, bring your own Docker image. And provisioning a database was like 5 lines of YAML, literally 5 lines of YAML, because we wrote some operators, which we'll talk about at the end. So what did the namespace look like? Hello? Yep. What did the namespace look like? Something like this. So all of this was the capability that we offered out of the box. So you can see from the top, VictorOps integration, Grafana, Prometheus, AWS IAM management, Heptio Arc. Now, Heptio Arc offers you on Kubernetes, for those who are not familiar, it offers you backup and recovery facilities. So you can run your workload, Arc would be constantly backing up your system. And in the event of failure, we as cluster admins can recover it for you. So we integrated that. Route 53, elastic load balancing, and this elephant thing is Postgres if you don't know it. Like, that's the database out of the box that Jupyter offers. And all teams had to do was just bring in their Docker images. Now, one might ask, like, if you're running so many, if you have 50+ teams and you've got 50+ namespaces, how did you do resource management? How did you, wouldn't teams step on each other's toes? Yes and no. Yes, they will if you don't do anything about it. But what we did was, for each of the namespaces, the green block you see, for each of these namespaces, the primary namespaces, we applied resource quotas, we applied network policies, and we applied default limits. That you will only get this much amount of CPU and memory. And the underlying cluster scaled. If you created a new namespace, the underlying cluster would automatically scale. People didn't have to worry about it. Dev teams didn't have to worry about it. Think about what they can do with all of this time if they don't have to think about these things. Fairly clear? Or if not, we can talk about it later. So few things, like this was more like an icing on the cake. So so far we've built Jupyter. We've added so many features on top of it. Now the next thing was, how do you get access to it? How do I log into the cluster? How do I see the dashboards and stuff like that? What we did, we integrated our AD with our Jupyter cluster, OIDC integration, OpenID Connect. And people would only need to use their domain credentials to log into the cluster. Now, this is really, really helpful. We saw the spike in usage. Why? Because people didn't have to remember another set of credentials. We didn't have to do anything extra in terms of onboarding a team. And onboarding was as simple as modifying an AD group. And that was it. I would heavily recommend, if you are planning to use Kubernetes on any cloud provider, doesn't matter if it is AWS or Google, use OIDC to help your teams log in. We also wrote an internal tool for generating the kube configs. For those who are familiar with Kubernetes, kube config is very, very important. You need to have it to access cluster from command line. And yeah, what the AD group did was it gave the teams access to the namespace. So you remember the green team namespace? This is how we controlled access. So the green team never had access to the shadow namespace. They only had access to their namespace. Operators. So operators is another very good concept in Kubernetes land. It's you codify the common operational tasks. For example, if you have to provision a database, codifying like the CloudFormation generation or the steps, API calls to create a database is an operator. And we did write a DB operator, which is open source on MYOB Technologies GitHub page. We built a DB operator, which just takes 5 lines of YAML, and it provisions an RDS, fully secure, fully backed up, SSL and everything, database on Postgres for you. So imagine this, like developers don't need to worry, they don't have to read the AWS documentation on RDS. And for those who have gone through AWS documentation, there is documentation for documentation. It's not easy. You get lost in the sea of documentation, and then you come out of the other end and like, oh, wait, I started with RDS, ended up with Dynamo. Happens. So teams don't have to do this. We also created alerting rule operator, which was like to create the VictorOps alerts, as I showed you. 2 lines of YAML, done. Teams don't have to worry about understanding Prometheus and everything. Now, in the spirit of DevOps culture, one of the things that I like to do is give credit when it's due. So this solution was not easy. Building Jupyter, as easy as it sounds, as I'm speaking at the moment, it wasn't easy. And the team of crazy engineers are up on there, especially the one on the bottom right, Prateek. Amazing. A lot of effort went into this. And that's why I would like to credit these great folks who have so much energy. And one thing we did was our customers, like our internal dev teams, were our high priority. We talked to them continuously. OK, what do you want? How do you want us to do this? So after, hello, go. Oh, sorry, wrong button. Now, we have our problem statement. We looked at our problem statement. We looked at our solution as to how that solution would have solved the problem statement. And some aspects in this solution can obviously drive the adoption. But there's a common notion. You build it, they will come. No, it doesn't work. You build it, you have to market it, or else they won't come. And even if they come, they will fight you tooth and nail. Hey, it's normal. It's normal human behavior. So what we did was, as I said, Jupyter was a package of powered by Kubernetes and capabilities. Our dev lead, John Contad, he created this whole Jupyter pack, like the slide pack, and we hammered that slide pack to every top-line manager. We talked about it everywhere. All internal conferences, we talked about this. Look, this is something we are building. Please use it. Give us feedback and stuff like that. And you would not believe the things like TLS, monitoring, dashboarding, alerting, it attracted so many people because they didn't want to do this. They didn't want to worry about TLS. Certificate expiry, most of us have been there. Yeah, certificate expiry is still a problem. We use Let's Encrypt, as you would remember from a couple slides before. It renews the search automatically. We don't need to worry about anything. We can sleep tight at nights. Yeah. We did some aggressive push. Oh, the other thing was we started this thing called Business Partner Program. And what that was, so our team, the replicants at Platform Engineering, were seconded to Cruise for, let's say, a day or 2. And we will teach the Kubernetes concepts to people. Not write code for them, but teach them the concepts. So they understand it, because at the end of the day, they would be maintaining the application side of it. So we did the business partner program. We did an aggressive push in our internal events, and we ran a lot of workshops. Teaching people Kubernetes is so fun. You won't believe. They break the cluster in so many ways. It's just a learning experience. But yeah, mad props to JC. He came up with this whole marketing gig, and he's our dev lead. Hello? Did I just skip one? Can I go back? Yep. Yeah, so now the thing is, how did we know what our customers wanted? So we created a Git repo. And we asked people to chuck in requests. We requested feedback, and we were really aggressive with asking for feedback. It was not like, oh, if you find time, give us a feedback. No, you have to get feedback. Give us the feedback right now, after the workshop. What is the feedback? I was just there like this. What is the feedback? Do you like it or not? Wouldn't let people leave the room. It was important because those were early days, and we didn't want Jupyter to fail. We want Jupyter to succeed because at the end of the day, we want our customers to succeed. And we publicize Jupyter. And one of the things that we do at MYOB is we have this thing called sensible defaults. And this is the control autonomy part that I was speaking about. Sensible defaults is, for doing new applications, there is a set pattern in MYOB. If it fits for your case, you should choose that, or else, if you are an exception, throw a letter, like talk to the community why you're an exception. If you're not, you have to follow those sensible defaults. It's kind of standards, but not in that harsh tone of standards. It's sensible, and it's default, so standard. And we communicated the value of Jupyter to all the developers. And to be honest, I have not seen something be adopted bottom up this fast. When we talked to our developers, showed them the value, they spoke to their managers. Their managers spoke to their managers. And it just became a de facto standard overnight. This slide is really, really important for me. It's something that I believe in. Open and transparent culture is what drives adoption as well. We were open about our failures. So like the Ingress failure I just talked about, we did a PIR, published it to our public channels. And people really liked it. Like, you're open about this. We can trust you. And 5 or 6 PIRs down the line, yeah, people started trusting us. Not saying that incidents were common, but we did PIRs on even smallest things, like why TLS certs went haywire. And one thing the PIR should be, they should be blameless. We should not focus on the why. Oh, sorry, we should not focus on the who. We should focus on the why. Almost did it. The why is important, why it failed. And when you write up that why and share it with your technical community, people are like, okay, I understand. This is how TLS works. Automatically, they will understand it and accept it. And you become this, you form this unforged friendship sort of a thing, which is very weird, but it's interesting. And people start believing you. Trust me, try this out at your place. And one of the other things that JC says is hearts and minds, bridges, not walls. Don't wall your project. If you build a project like that, don't just expect people to, come and adopt it. Create paths for easy acceptance. Yeah? Fairly clear. I'm just, throwing random words, so I've got another minute. And at last, conclusion. So if you were sleeping throughout my talk, this is something I would like you to take away. Listen to your developers. They are really, really in need of help. They don't want to solve infrastructure problems. They want to write blockchain. No, sorry, don't work on blockchain, but solve interesting problems. Yeah? Something I like to promote is empathy-driven infrastructure. Your infrastructure should be helping something. Don't build because it's cool. Build because it is solving a business requirement. It is solving a business problem. Yeah? And the third one is very cheesy. Create a cluster of learning and trust. Please do. People should be able to experiment. One of the benefits of Jupyter is teams experiment quick enough that, and I can on record say this, now our time to production from months is down to 2 hours. 2 hours. It's a very big deal for a company at the scale of MYOB. And I can't read it. Remove the undifferentiated heavy lifting. So the lead time to production we reduced from months to 2 hours is, I do not know if there is a bigger success metrics for us. And quite literally, that is what has driven the adoption. And this was our story for driving adoption. Thank you very much. Let us know if you have any questions around Kubernetes or would like to understand more about Kubernetes or as to how we did this. But that's our story. Thank you.